Welcome back to the deep dive. So, for months now, we've really been focused on, building the perimeter, the digital firewalls, the secure networks, all those access controls, basically defending the fortress walls. But what happens once an attacker, or maybe even just a careless user, actually gets inside? Okay, let's unpack this. The most valuable thing inside that fortress, the real crown jewels, it isn't the operating system or the virtual server, it's the data itself. Today, we're shifting our focus completely. We're going inside the vault to talk about securing the data, making sure that even if someone gets to it, it's completely unreadable. And just as important, that we're meeting all those mandatory legal and regulatory requirements for keeping it safe.
That's the critical pivot, really. It's moving from network defense to data defense. And the controls you use are, well, they're totally different. You have to look at it through two lenses. First is comprehensive encryption, just making the data nonsensical to anyone without the right key.
And the second?
Survivability and retention, making sure the data exists when you need it, and just as crucially, is destroyed when you don't.
Let's start with encryption then. That feels like the most foundational layer. This is where I see people get tangled up in the terms at rest versus in transit, because the tools for each are so separate. Can we just clarify that right away?
Absolutely, and it's so important to separate them because they protect against completely different threats. Think of encryption at rest as protecting your static data.
So data that's just sitting still.
Exactly. Data on a hard drive, in an S3 bucket, in a database. Tax records, customer details. If it's not moving, it's at rest.
And the idea is if someone, say, walks out with a physical hard drive.
The data is still safe because it's encrypted. The theft of the medium doesn't mean the theft of the information.
Got it. And what's the go-to tool for managing that static encryption in the cloud?
The star player, the absolute governance hub for this is AWS KMS, the key management service.
KMS?
Right. And it doesn't just encrypt the data. It manages the entire lifecycle of the cryptographic keys themselves. It plugs into almost every other AWS service, creating this central control plane just for your keys.
Okay, so that handles the data in the vault. Now, what about data moving to or from the vault? Data in transit. This sounds like we're not securing the cargo anymore. We're securing the tunnel itself.
That's a perfect analogy. Encryption in transit protects data while it's actively moving across a network.
Like me connecting to a website.
That's one example. Or two internal cloud services talking to each other. Anytime data is traveling, it's vulnerable to someone listening in, eavesdropping.
So we're talking about SSL/TLS certificates here,
Yes.
creating that secure pipe.
Precisely. And in the AWS world, the tool for that is AWS Certificate Manager, or ACM. ACM handles everything, getting the certificates, deploying them, rotating them automatically.
Okay, so it's a clear separation. KMS protects the contents of the vault. ACM protects the delivery channel.
You've got it.
Let's go back to KMS for a minute, because this is where, compliance architects really earn their money. You have two main flavors of keys. AWS managed keys and then customer managed keys, or CMKs. Here's where it gets really interesting. Why would anyone pay for and take on the extra work of CMKs when AWS gives you managed keys for free? Why does that control matter so much?
It's the classic trade-off, isn't it? Convenience versus accountability. AWS managed keys, look, they work. They're free. They're automatic. But that convenience comes at a huge cost in governability. If you use an AWS managed key, you cannot see the underlying policy that says who can use that key. And this is the big one, you can't control its rotation schedule.
So an auditor comes in and says, show me proof you rotate the keys protecting customer data every year. And with AWS managed keys, my answer is basically, trust me, the cloud provider handles it.
And for a lot of compliance frameworks like HIPAA or PCI DSS, that's just not good enough. That's why you have to move to customer managed keys. With CMKs, you get total visibility. You write the key policy, you define the permissions, you own the risk, and you can prove it.
And you mentioned rotation. That's the biggest functional difference. Why is forcing a key rotation on a schedule so critical for compliance?
It's all about limiting what we call the blast radius.
A blast radius.
Yeah, think about it. If a key is somehow compromised, an attacker can only decrypt the data that was encrypted with that specific version of the key. If you use one key for 5 years and it leaks, 5 years of data is exposed.
But if you rotate it every year?
The maximum exposure is only 1 year of data. With CMKs, you can enable automatic key rotation. That's a huge non-negotiable checkbox for most large companies. You get to set the strict governance while AWS still handles the underlying difficult parts of the key infrastructure.
Right. So the lesson is that free and convenient often means you're sacrificing that deep, auditable control. Understood. So we've locked the data down with the right key. But data has a lifespan, right? It's born, it lives, and eventually it has to be destroyed. This whole journey is driven by compliance and, let's be honest, by budgets.
Absolutely.
Sometimes you have to keep data for a decade, like medical records. Other times you must delete it to meet privacy laws or just to save money. This seems to lead us directly into lifecycle management.
And this is where automation becomes your best friend. S3 lifecycle policies are probably the most powerful tool for this, for automating data management, cost, and compliance all at once.
Can you walk us through a real-world example, something that saves money and keeps the lawyers happy at the same time?
Sure. Let's use a 7-year tax record example. When that data is new, it needs to be accessed quickly, so it lives in the fastest, most expensive storage tier S3 standard.
Okay.
You set up a lifecycle policy. Rule 1. After 30 days, transition this data to a cheaper tier, like S3 standard and frequent access. Right away, you're saving money.
Because you're not touching it every day anymore.
Exactly. Then, Rule 2. After 90 days, move it again, this time into S3 Glacier Deep Archive. Now, your storage cost is pennies, but you've made a trade-off.
The retrieval time. You can't get it back instantly.
Precisely, and that's the key architectural decision, right? You're balancing the cost against how quickly you need that data back your recovery time objective. And the final step is the most important for compliance.
The deletion.
Rule 3. After 2,555 days or 7 years, automatically and permanently delete the data. Now you've managed its entire life cost, retention, and final destruction with one automated policy.
That covers the timer and the budget. But what about the ultimate lock? What if I'm in finance or healthcare and I need a guarantee that no one, not my CTO, not a rogue admin, can tamper with a file for a set period? I need something that goes beyond human access controls.
Now you're talking about data immutability, and for that, the tool is S3 Object Lock. It enforces the worm principle, write once, read many.
I've heard there's a specific setting here, compliance mode. How serious is that lock?
It is the ultimate commitment. When you set an S3 object lock to compliance mode with, say, a 5-year retention period, that object is absolutely, positively untouchable until that timer expires.
I get that it blocks normal users, but what about the highest privilege? The root user of the entire account. Surely they can just delete the whole bucket.
No.
Seriously.
No. And that is the monumental severity of compliance mode. Once it's locked, the object and the bucket it's in cannot be deleted or modified by anyone, not even the root user. The system itself enforces the rule, overriding any human or administrative action until that clock runs down.
That is staggering. The system is literally tying the hands of its owners to guarantee compliance.
It is absolute assurance. You remove the human element from the equation entirely for that retention window. That's why it's a requirement in certain fields.
Okay, let's pivot from prevention to preparation. We've locked the data down, we've set its life cycle. But what happens when things just go wrong? We need a real auditable disaster plan. We need backups.
And if you're running a complex system today, you've got databases, you've got file systems, configurations, all living in different services. If you try to manage backups for each one separately, EBS snapshots here, RDS backups there, it's a nightmare.
It sounds like a recipe for forgetting something critical. And a nightmare when an auditor asks for your unified recovery plan.
Exactly, which is why the centralized approach is, well, it's non-negotiable. The tool here is AWS Backup. It's that single consolidated hub for managing backups across almost all your services.
So instead of juggling 5 different backup schedules, I just made one master backup plan.
You define one backup plan, and then you apply it using tags. You can create a rule that says, anything tagged critical prod must be backed up daily, kept for 90 days, and stored in a separate secure vault. It eliminates that risk of human error.
That handles the consolidation part. But for real disaster recovery, there's one word that always comes up: distance. A problem in one data center is bad, but a regional disaster could take out an entire geographic area.
For true business continuity, distance is your only real safeguard. You must have cross-region replication. A backup that lives in the same city as your production data isn't a disaster recovery plan. It's just a data restoration plan.
Can you give us a concrete example of why that's so critical?
Of course. Let's say your main operations are in Northern Virginia. A huge event happens. A massive power grid failure, a regional storm. If your backup is also somewhere in Virginia, it might be affected too.
It's vulnerable to the same regional failure.
Right. True resilience means you are replicating that data, maybe in real time, to a region thousands of miles away, like Oregon or Ohio. That geographic separation is your insurance policy against a localized catastrophe.
And this all ties back to those terms auditors love, RPO and RTO.
It all comes back to them. Recovery point objective. How much data can you afford to lose? And recovery time objective. How quickly must you be back online? All these controls we've discussed are just tools to meet the specific RPO and RTO targets your business requires.
So what does this all mean? If you're building a system where data security is truly the top priority, you can boil it down to a kind of final checklist for a secure data vault. That checklist looks something like this. Encrypt your data at rest with KMS, and really you should be favoring customer-managed keys for that auditable control. Secure your data in transit with ACM certificates. Automate costs and deletion with S3 lifecycle policies. Then, for those high-stakes situations, you implement S3 object lock in compliance mode for absolute immutability. And finally, you guarantee survivability with a centralized plan in AWS backup, making sure you have cross-region replication to survive a true disaster.
It really reframes data security. It stops being an afterthought and becomes a core automated part of your architecture. And it reinforces that these tools aren't just tech features. They're business insurance policies designed to minimize your legal and financial risk.
A perfect way to put it. The intersection of technical control and business outcome. But before we wrap up, let's leave you, our listener, with a final provocative thought that builds on this idea of the ultimate lockdown.
If we use these immutable controls like S3 object lock in compliance mode to satisfy a 5-year retention mandate, intentionally making data undeletable by anyone, even ourselves, what happens when the business has an unexpected, urgent need to, say, migrate everything or tear down that system within the 5-year window? And since compliance mode ties everyone's hands, what legal and financial responsibility does the original architect have for setting an immovable timer that now prevents a critical emergency change?